Alright, so when we were last together, we had started talking about alkanes, as soon as I pull this up here, and finished up, I believe, with the methyl alkane that we looked at, the longest chain, those type of things. So we're going to jump in where I left off. I think we're about halfway. This is the 2-methylbutane. I believe this is where we left off. So we're going to pick up here, move forward. Another example here of IUPAC nomenclature for alkanes. You have this, you've got 3 rules at the bottom. Number 1, find the longest continuous chain of carbon atoms. Okay, so that's rule 1. And then rule 2 is number them in a way that gives all the substituents the lowest total numbers possible. And then number 3, you want to prefix the name of the parent alkane with the number and name of the substituent. Okay, so you have one here to look at as well. And you're going to get some practice with these. But no, this is new stuff for you, and it's kind of a refresher for me as well. I don't teach this quite as often, except for just this time in the spring. Um, so you could have this, right? So if we use those 3 rules that we talked about, if you see, we could number this from the left to right. This is 1, 2, right? So there's something on 2. Whether if we came the other direction, it would be 1, 2, 3, and that would be higher than going 1, 2. So we're going to name this 2, right? And this is a trimethyl, okay, because of what you've got going on there, right? Hexane. So there's one on 2, there's one on 3, and there's one on 4. So there are 3 of them, and they exist on the 2nd, 3rd, and the 4th carbon. So that's 2, 3, 4. And because there's 3 of the methyl groups, we say trimethyl hexane. So not too complex, excuse me, but it's definitely new for you. I'm aware of that. Some more nomenclature for alkanes. If more than one kind of substituent is present, the alphabetic order of the constituents take priority over the number of the constituent when numbering the parent chain, right? So here what you've got is the 3-ethyl, right? Because you got 2 of these here instead of methyl. And then the 2-methyl, right? We'll come back to the structure later, but and then if you number your chain 1, 2, 3, 4, 5, 6, you know that's hexane. So we're dealing with hexane here. On the 2, you've got a methyl group, and on the 3, you have an ethyl group. So you might want to write those down, right? And then over here, you've got 1, 2, 3 ethyl, right? Because there's 2 groups attached to it. And then on 4 and 5, you have what we call dipropyl octane. Now octanes because it's got 1, 2, 3, 4, 5, 6, 7, 8, right? So like I said, you're going to get practice with these, and you can ask questions in class if you need to. But a lot of this is just going to come from you practicing these. Nomenclature for alkanes follow these 3 rules. Number 1, separate numbers from letters with hyphens. Number 2, separate numbers from other numbers with commas. And number 3, don't separate the last substituent name from the parent alkane chain. And so what you have here would be what we're looking at. So you've got a 4-ethyl hyphen 2,3 hyphen dimethyl hyphen 5 hyphen propyl nonane. That means there's 9 in that chain. Okay? So you do these things first. Number 1, where all the arrows are pointing. Number 2, you do this, and then number 3, you would do this. Again, I know it's a lot to remember, right? But a lot of this is just straight memorization. That's all there is. Okay, so it's a little different. Line angle structural formulas for alkanes. Line angle structural formulas describe carbon to carbon bonds, right? So when you see this, you know there are carbons here, right? Or if you see this, there are carbons here. But this is the same thing as a straight line here. And this is the same thing as what you see over here, right? And so if you know that there's a carbon here, 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 and here, right? So that would be, this one has 1, 2, 3, 4, 5, 6. So you got, let's see, 1, 2, 3, 4, 5, 6. Yeah. So you got 1, 2, 3, 4, 5, 6 carbons on this chain. On this one, you'd have 1, 2, 3, 4. 1, 2, 3, 4. Right? So that makes sense as well. Make sure you get all these in your notes, okay? You need these notes for reference. I cannot stress that enough. If you don't have good notes from this one, it's going to be a struggle. I'll admit that. There's a lot to memorize. I know that. But again, you have to have these notes to reference back to. All right, classification of carbon atoms. The carbon atoms in organic structures are classified as primary, secondary, tertiary, or quaternary, depending on the number of other carbon atoms that bound to them. So primary is what we call 1 degree, right? Primary is 1. Means the carbon is bound to one other carbon atom. Secondary means there's 2 carbons. Tertiary means 3, and quaternary means 4, right? And so you can see that down here. So this is a quaternary because it's bound to this carbon, this carbon, this carbon, this carbon. So there are 4 attachment points. This is primary because it's only 1. This would be secondary. It's got one on the left and one to the right, so on and so forth. I believe that pretty much makes sense. But again, you've got to be able to practice it and have these notes to reflect upon. All right, so we were in alkanes, so now we're going to talk about branched chain alkyl groups. Sometimes branched chain substituents are encountered. These are named according to the parent alkane from which they are derived. So you can look down here. The substituent here is a 3-carbon alkane. So this is propane at the point of attachment to the secondary carbon of the alkane. So you would name this is at the 1, 2, 3, 4 mark. So it's 4, and then it's isopropyl octane. And the octane came from naming this 1, 2, 3, 4, 5, 6, 7, 8 chain, right? And the isopropyl has to do with the attachment point. Same thing over here. Again, you're on the 1, 2, 3, 4 carbon, so you're going to put 4. Right? This is tertiary because it's got 1, 2, 3, 4 attachment points. So it's 4 tert or 4 tertiary, right? And this is again octane. So, and then you've got this is what we call a butyl group, right? So this is an isopropyl group. This is where we get the term isopropyl alcohol, right? And this is a butyl octane. This is a butyl group. So again, lots to memorize. I would highly suggest note cards or something so that you get some of these things down, and you're going to get practice with them as we go through. So here is your branch chain alkyl groups. You got your isopropyl group. Draw these out. Draw these out. I repeat that. You've got your isobutyl. You've got your secondary butyl group, and you've got your tertiary butyl group. Right? So make sure you write those out. Sometimes instead of saying tertiary or secondary, or right, you're going to see things like tert for tertiary and sec for secondary, right? They aren't capitalized, but iso, right, is capitalized. Also notice that, okay? So again, more to memorize. I'm aware of that. Branch chain alkyl groups. Given a choice between unbranched substituents and branched substituents, use unbranched ones for naming. Okay, unbranched ones for naming. So this would be, you've got something attached to the 2 and to the 3, right? But the 3 has more of these, so we're going to say 3-ethyl, 2-methyl, right? And I think if you count these, you have 6. So this is 3-ethyl, 2-methyl hexane, right? That's it. Okay, so the 3 and the 2 are a little different here. Cycloalkanes, we sometimes call these ring structures, right? You can have a 6-ring structure where you have 6 carbon attachments, 1, 2, 3, 4, 5, 6. That's cyclohexane, right? But the general formula for a cycloalkane is CnH2n, right? So that's your general formula. We've seen that before as well, okay? But cyclic alkanes are alkane chains where the end carbons are linked together, right? And so there's no straight line. It's just a solid ring structure. So sometimes we actually refer to these as rings. Okay. And I'm going to check time just to see how much time. Okay, we got another 3 minutes or so. All right, so let's continue on. Cycloalkanes, here you go. You've got cyclopropane, which we see as a triangle, cyclobutane, which is a square, cyclopentane, which is a pentagon, and cyclohexane, which is a hexagon structure. Notice also the formulas: C3H6, C4H8, C5H10, C6H12. So whatever the C is, you're going to have double the H's. That's pretty common. Okay. Make sure you draw those out. All right. Let's talk about naming the substituted cycloalkanes. If one substituent exists on a cycloalkane, no numbering is needed to denote its location, right? So this is just ethyl cyclohexane, right? And so the cyclohexane is here, right? And this is an ethyl group, because you've got two. So it's an ethyl group. So this would be ethyl first, and this is cyclohexane. That's pretty straightforward. That's the way you name those. It gets a little bit more hairy as we go here. If two substituents are present, then the ring is numbered. It follows alphabetic priority, right? So again, this first one, right, you've got a ethyl group. The two, you've got a methyl group, and then that's it, right? This is cyclohexane again. So one ethyl, two methyl, and then cyclohexane. Okay. Over here, you've got a one methyl, two ethyl, right? Three has nothing. Four has propyl, right? Three for propyl. And so this would be called, since the ethyl's first, we go with alphabetic. That's what all this red is. So two is ethyl, then we go to methyl, then the propyl, right? Because E comes before M and M comes before P in our alphabet. So hopefully you can see that. Draw these out. Again, you need great reference material for this. And this PowerPoint is one that I really think does an overall outstanding job of breaking these things down, making it pretty simple so that you understand it. There's a lot that if I just said read the chapter or go look this up, you can find the answers, but you don't understand them. And I know right now you're probably thinking, yeah, I don't understand these right now. But you're going to have practice. You got me to lean on and ask questions. But you really are going to have to sort of buckle down this last 5 weeks or so and jump into this organic just so you have a better understanding for this, especially if you're going to go pharmaceuticals or medicine, veterinary, anything like that. You're going to have to really know your stuff when it comes to organic structures. Okay, that's the way it works. Okay, then we've got isomerism in cyclohexanes. Let's see, this might be a good place to stop. Let's check here. Yeah, we're going to stop right here at this slide. So I'll talk about this slide, and then we'll call it a day. Isomerism in cycloalkanes, sorry. Constitutional isomers are possible for cycloalkanes, having 4 or more carbons. Here in the square, you see C4H8 cyclobutane, but it could also look like this, right? So you could have, here you've got carbon 1, carbon 2, carbon 3, carbon 4. Here you've got carbon 1, carbon 2, carbon 3, carbon 4 is way out here. And so this is called methyl cyclopropane, right? These isomers differ in the way the carbon atoms are connected together. That's what we call constitutional isomers, right? And an isomer just means that it's the same thing, just in a different look or a different structure, right? That's basically what we're saying. So if you were to see both of these, most of you would say, those are two different. They're two different things. But remember, just count your carbon links. There's 1, 2, 3, 4. 1, 2, 3, 4. So they both are the same thing, C4H8, right? Again, I told you, organic chemists are a lot of times lazy, and so we don't like drawing out any more than we have to. So you don't see all the H's, right? At this point, you don't even see the carbons. You see a square and a triangle with a stick on top, right? And you're supposed to be able to take these and understand